So now that we've learned how to design experiments, we're going to have to conduct experiments. And one of the things that we have to do when we conduct experiment is collect data. We have to collect data and analyze it so that we can draw conclusions about the data that we collected. So we should know why scientists collect data. They collect data so that they have information that they can use to make inferences about how variables affect things. So when we manipulate a variable, what effect does it have? And the data will show the effect. And then when we have that data collected, we can use it to make inferences, draw conclusions about why things happen. The most commonly collected data is data that's collected in charts. So I'm going to use this example showing how we collect data in charts. The rows are the horizontal parts of the chart. The columns are the vertical parts of the chart. So if you take a look at this data chart, the rows are the trials and the columns are the different groups. We can also represent data in graphs. Usually scientists collect data in charts and then represent it in graphs. It just makes it easier for the person reading their information to see what the data shows. They could give the person the charts, but this is a better representation of the data. It allows people who are trying to do some research to see what the scientist found out. It's much more visually appealing and it's easier to read. It's a quicker way to read data when it's presented in a graph. One of the challenges that students have is not understanding how to read a data chart or a graph. So we're going to briefly go over this and then we'll do some practice chart and graph reading in class. So the first thing that we have to do is look at the title. The title gives us so much information. So every time you see a chart or a graph, you want to make sure that you read the title so that you can understand what the chart or the graph is going to tell you. Then in a graph, you have to look at the axes, which is the X or the Y axis in the graph. Or in a chart, you look at the headings. You must read the headings and read the axes so you'll understand what the information is in the chart or the graph. So here's an example of a chart. And so these are the rows that go across horizontally. So trial 1 is in row 1, trial 2 is in row 2. And these are columns. Columns go vertically. And so if you take a look, this chart says the growth of plants with different fertilizers. So I'm going to be reading how plants are grown in different fertilizers. So I've got a control group. This one did not get any fertilizer. And in trial 1, it grew 10 centimeters. In trial 2, it grew 12 centimeters, and in trial 3, it grew 9 centimeters. And the way I know that is because it says what unit of measurement was used. If we take a look at test group 1, we're talking about the group that was grown with Miracle-Gro, and the growth of Miracle-Gro fertilized plants in trial 1 was 17, trial 2 was 15, trial 3 was 19. Similarly, we've got another group that was grown with Tasty Food, and then another group that was grown with compost. So we can read what growth occurred in which trial. So this scientist did the experiment 3 times because trial means attempt. So they tried it the first time, then they tried it again, and then they tried it again. And scientists always want to repeat their experiments so that they can make sure that their data is reliable or valid. And it looks pretty reliable here because the numbers look quite similar to one another over each of the 3 trials. So here's the same data, but it's shown in a graph. Again, it says the effects of fertilizer on plant growth, and we do want to read the axes. So the y-axis shows the growth in centimeters, and here's the numbers: 0 centimeters, 5, 10, 15, 20 centimeters. And the x-axis shows the different trials. And if you look, each bar is represented by a color, and so the color represents the columns that we saw in the chart. So the control group column, that's the green bar in trial 2, in trial 3. So those 3 represent the control group. Then the yellow shows the miracle group over the 3 trials, tasty food, and then compost. And you can read the graph very easily. So if we look at trial 1 and somebody says which plant showed the most growth in trial 1, we will say the compost plant showed the most growth. It looks like about 22 centimeters. So you can read the graph and see it very easily. Now we have to understand how to analyze data. And data analysis sounds really scary, but it's really easy. Data analysis is just the way that we describe the data. We take a closer look at it. Analysis means take a closer look at it. So we're going to describe it in words. So whatever the chart says, we're going to describe it using words. So I'm going to do a data analysis of our data chart. And if you notice, I added another row. And what I did was I took the average growth over the 3 trials. So I only have to refer to one number when I'm analyzing the data. So if I take all 3 of these numbers and add them together and then divide by 3, I get the average growth for the control group. Same thing, I've got the average growth here of test group 1, which is the Miracle-Gro, the average growth of the Tasty Food fertilized plant, and then here the average growth of the compost fertilized plant. And so here is my data analysis, which is a description of the data using words. So if I read this, it says, when looking at the data collected, the control group showed an average growth of 10.3 centimeters over the 3 trials. So I'm telling you that I took an average and this is how much the average was. In the next sentence, I say Miracle-Gro showed a greater average growth, almost 7 centimeters greater average growth over the 3 trials. Then I go on to describe Tasty Food. And I say that Tasty Food doesn't show much difference. So if you look here, there's 10 centimeters of growth in Tasty Food and 10.3 centimeters of growth in the trial or the control group. So there's not much difference. And I say that in my data analysis. I say that in my statement. The next one is the compost fertilized. So I'm going to describe it. So I'm going to read it. It says, the compost fertilizer plants had the most significant difference in growth, with an almost 100% improvement in plant growth over the non-fertilized group. So here's 20.3 and 10.3. That's almost 100% difference. So it almost doubled in growth using the compost over not using any fertilizer. And then I go and make a statement that infers. So it says, you can see by this data that there is a visible difference in growth of plants that have been fertilized with Miracle-Gro and compost. So Miracle-Gro, pretty big difference, and compost, pretty big difference. There is no difference in growth when you compare plants fertilized with tasty food and non-fertilized plants. And you notice tasty food is 10, non-fertilized is 10.3. Then I go on to say the compost fertilized plants were over 3 centimeters on average taller than those treated with Miracle-Gro fertilizer. So I look here at the highest and I compare it to the next highest, and I show that 3 centimeters, that's a big difference. So I can show with my data what the numbers mean. That's what a data analysis is. And your data analysis paragraph or description should match what the graph shows. And if we take a look, it does. It shows that the compost grown fertilized plants had a much bigger growth than the control. It shows that the tasty food grown plants had a similar growth to the control group. And then the last thing that you want to do is draw conclusions. So conclusions must contain these 4 things, okay? So they must state whether the data supports their hypothesis or refutes their hypothesis, and make sure that you restate the hypothesis in that statement. It also must state the errors that may have come up during the experiment. It must also state what further investigation could be done to corroborate the evidence. And when I say corroborate, that means to back up, to come up with evidence that is the same or supporting the evidence that we found already. And they also must reflect upon what kinds of applications can this information be given to. So I'm going to show you an example of our so here's an example or sample conclusion. I put it in bullets, but it should be in a nice paragraph, but I just wanted to show the 4 different things. So the first thing that we do is say whether or not the data supports or refutes our hypothesis and restate the hypothesis. So it says at the close of the experiment, the data does not support the hypothesis that if plants are grown with varying types of fertilizer, that Miracle-Gro could produce the greatest growth. The data shows that although Miracle-Gro did produce significantly greater growth than the control with no fertilizer, it was the plant group that was grown with compost that showed the greatest difference in growth. That is a conclusion. So make sure that you include those points when you conclude. The next thing that you have to include is errors, sources of error. And for example, in mine, I just made this up, but while conducting the experiment, there were some issues that arose that may have had an effect on the results. The air conditioning in the lab was not working for 2 days, causing an increase in temperature and humidity. This may have caused a difference in the results. Further investigation should be undertaken to determine if this was a factor in the results. So if you have errors while you're doing your experiment, you have to state them in your conclusion and explain what they are and how you could stop the errors from happening in a different experiment, or how you could continue to experiment, making sure that these errors didn't affect your results. The next thing is that you have to talk about how you can corroborate the evidence, or what you can do to further the evidence, and in this case I said experimenting with different plant types and having a larger sample size would be the next step in the process of investigating the effects of fertilizers on plant growth, as a larger data set will give a better look at the differences in the fertilizers. And then the last thing that you should do is think of ways that your study or your experiment can be used in wider society. This study and others of this type can be used by citizens to improve plant production in their gardens, and also by larger agriculture operations to improve crop yield.